Next, I want to look at a couple applications of right triangle trigonometry. And these are really great because they really do affect the real world in many ways. So one application is something that we call angle of elevation or angle of depression. And I drew an example here as a picture to kind of help illustrate that. So let's say you have a tall building or any size building, and there's a person in this window standing right here, okay? Now this horizontal line is drawn where the person is looking. So that would be exactly where their eyes are coming out, okay? So that would be that horizontal line. So let's say the person is looking up at the birds in the sky, maybe they're flying away. Well, the angle from that horizontal line up to where the birds are is called the angle of elevation. It's going up, it's above the horizontal line because you're looking upward. So it's called elevation. Or let's say that same person is looking down at a car in a street far away. Again, they're looking downward from where they are. So that's called an angle of depression. So this horizontal line is exactly where that person would be looking if they were looking straight ahead, or whatever the object is that you're measuring from. Here I'm talking about a person in a building. So their eyes, wherever they are, as tall as they are in that building, that straight horizontal line coming out, that is that horizontal line. And then you have the angle if they look up, right? That's your angle of elevation. Or if they look down at something, that is the angle of depression. So we're going to do some examples with these. So here's one. Citing the top of a building, a surveyor measured the angle of elevation to be 22 degrees. So if it's elevation, we're going upward from something. The transit is 5 feet above the ground and 300 feet from the building, and we want to find the building's height. So let me draw you a picture here to start. And obviously it's not going to be the best, but you can get it. So I know I'm talking about a building, so I'm just going to draw my little building. Okay, and there's the door. So there's my building. So there's a surveyor who's measuring different angles and lengths and things like that. He's trying to figure out the height of this building. And he has a tool called a transit. I don't know if you've seen one before, but a transit, it kind of looks like a tripod. They're often yellow. And usually construction workers will have them, or they may not be construction workers, they're probably a surveyor, but they have like construction vests on, something that's high visibility so that you can see them. And they really look like these yellow tripods. And it's a really great tool, and it can help you measure these angles. So there's a person, let's say, standing over here. Obviously my person's probably too tall. And they have this little tripod that kind of measures these angles. So what's happening is we're measuring from this transit, so from this tripod. So they're telling us that the height of this tripod is 5 feet. So it's 5 feet off the ground. That's where we're measuring from. That's where that horizontal line gets drawn from. And then the angle of elevation going up to the top of the building right here is that 22 degrees. The other thing I know is that the transit is 300 feet from the building. So that this length right here from the transit to the building is 300 feet. Okay. And what we're trying to figure out is we're trying to figure out the height of the building. So I want to know the whole height here, right? I want to know how tall it is. Now, how else could you find the height of the building? Well, you could maybe go back and dig through old building records and things like that to see what the original height was planned for. Hopefully they didn't change anything, or, you know, the building hasn't settled or anything like that, because that could affect the height. So this is one way to actually find the height of the building, because you probably aren't going to be able to climb up and measure that height any other way. So we can use trigonometry to figure that out. Now, here you want to be a little careful. Notice that, you know, this horizontal line here is not on the ground. It's actually 5 feet above the ground. So you do know that this first part of the building is 5 feet, but we don't know what the rest of it is. So we're going to call this A. And hopefully you're noticing here that I have a right triangle. So I've actually created a right triangle in this case, and I can go ahead and find that value A. So we got to think a little bit here. Think about what I know. I know this angle is 22 degrees. I know the length, right? If I think about this, this is my right triangle trigonometry. So opposite of the right triangle would be the hypotenuse. So I don't know the hypotenuse. and I don't know this leg here. So I know the angle, and if I'm thinking in terms of the angle, I know the leg adjacent to it. And I really want to know the value opposite of it, right? So if this is my angle, then this is the value adjacent, and this is the length opposite. And that's what I'm trying to figure out, and this is what I know. So think about it. What trig function relates opposite and adjacent together? Well, the answer there is going to be tangent. So tangent of theta is equal to opposite over adjacent. So if I fill in my values, well, my theta is 22 degrees here. So tangent of 22 degrees is equal to, I don't know the opposite, that's A, and I know my adjacent is 300 feet. So I've made a little equation for myself to solve, and I can go ahead and solve this. I can cross multiply here. So I end up with tangent of 22 degrees times 300 is equal to A. Now, this tangent value is not exact. It's not a common one, so I am going to use my calculator here. And again, you just want to make sure that you check your mode on your calculator. I need to make sure I'm in degrees, which I am. That's a really common mistake. Students make the mistake all the time. They're in the wrong mode. So make sure you're in the right mode. I type tangent 22, and then I'm going to go ahead and multiply that by 300. And I get that A is about 121.207, we'll say 9. And we were talking about feet here. Now, don't forget, we're not quite done, right? That was this part, but the whole height of the building has this extra +5 in it. So the height of the building is going to be 5 plus that 121.2. I'm just going to round here. So it's about 126.2 feet tall. And I just rounded to the nearest tenth in this case. So you'll have to see, what the problem wants, how specific you need to be there. Maybe 0.2 feet makes a big difference. So you would want to round appropriately for that problem. All right, here's our second example I want to do. It's similar, but this one's a little bit different where you have to find the angle rather than a side or a length. So here, a building that is 21 meters tall casts a shadow that is 25 meters long. Find the angle of elevation of the sun to the nearest degree. Okay, so again, here's kind of my rough picture. I have my building. The building's 21 meters tall. The sun is overhead of the building, probably a little bit behind it or above it, where it's casting a shadow down, and that shadow is 25 meters long. And we're looking for the angle of elevation here. So we're looking for that angle really from that ground level up to that sun to figure out that's casting the shadow. So that's what we're looking for here. So think about your trig functions. Here's your angle, right? This is the direction that we're looking from. So if I think about this being my angle, well, here's my side of my right triangle, or here's my angle for my right triangle. This is the hypotenuse right across from it. So I don't know the hypotenuse here. I know that 21 meters, which is the opposite, and I know the 25, which is the adjacent. And again, opposite and adjacent is always determined by the angle. So here, opposite of this angle is the 21, adjacent to it is the 25. So think into your functions. Which one do I know relates opposite and adjacent? And the one that works there is tangent. Now you could use cotangent too, but it's just not as popular, so you don't find it on your calculator and things. So I would recommend trying to stick with sine, cosine, and tangent only, rather than the other 3 less used trig functions. So again, I'm going to use tangent here because tangent of theta is opposite over adjacent. I don't know the theta here, so it's going to be tan of theta. The opposite is 21, and then the adjacent is 25. Now, we're not quite done. We do want the answer. So we want the answer to the nearest degree. So we're going to be in degree mode here. And you actually have to use your calculator here. So if you need to find the angle, What you're going to use is you're going to use an inverse trig function. On your calculator, and you would use the one that compares to what you have here. So if I have tangent, I would use inverse tangent, which looks like this. Okay. If I was trying to find sine theta, I would use the inverse sine. So it would be the sine with the little -1. If I had cosine theta, I would use cosine with the -1. So that little -1 refers to the inverse in this case. So if I go up to my calculator, again, I just have the TI 8384 app here. You'll see that my calculator has that function right there, inverse tan. Other ones, a lot of them will have it. You may have to look around a little bit, but you can find it. If not, I'm sure you could Google one online to use if you need to. Again, this app that I'm using for iOS is one of my favorites. It's called Graph and Calc 83. Sometimes the graph part is spelled with an F. Same one. So I'm just plugging in my computer real quick. Or if you have an Android instead, the one students tend to like is Graphing Calculator at x84. Those are just two of them, but really there's so many that you can buy or download for free. So just get one that works for you, and that's fine with me. So what you're going to do here instead, how you enter it, at least on this calculator, is I would press second and then that tan feature here, and you'll see it brings up the inverse tan. And then I actually put in the right side. So 21 divided by 25 and hit enter. Now, do make sure you're in the right mode. So my calculator, I'd already checked, was in degree mode, which is what I want my answer in. So the theta here is about 40.03 degrees, or that's pretty close to 40 degrees. So it's about 40 degrees in this case. So again, every calculator is a little bit different. You may have to play around on your own calculator to see how to enter it. For the 8384 series, and similar, again, you hit that second button and then the tangent, which gives you the inverse, and then you put in the right-hand side. Now you know the answer for this problem. So on your calculator at home, what you're going to do is you're going to play around with the calculator until you find out how to get that answer of 40. Because if yours, it works a little bit differently, you want to make sure that you know how to use it before you start getting into homework and tests and things like that. So this one would be about 40 degrees.